の虜になってしまえばきっとこの夏は充実するのモード噂の Dreaming Girl
The following sound waves have what velocity?
Using this magic triangle, we could identify what formula could be used.
Given the frequency of 20.0 Hz and the wavelength of 17.2 meter, to get the velocity, we are going to multiply frequency and the wavelength. 20 Hz multiplied by 17.2 meter is equal to 344 meter per second. We have now the frequency of the letter A, and then let's move on to letter B. Given the frequency of 200 Hz and the wavelength of 1.72 meter. 200 Hz multiplied by 1.72 meter is equal to 344 meter per second. Given the frequency of 2000 Hz and the wavelength of 17.2 centimeter. Since it is centimeter, we are going to convert it into meter. In 1 meter, there are 100 centimeter. So 17.2 multiplied by 1 and divided by 100 is equal to 0.172 meter. 2000 Hz multiplied by 0.172 meter is equal to 344 meter per second. We have now the velocity of letter C. Letter D, 20,000 Hz and wavelength of 1.72 centimeter. We are going to convert centimeter into meter. There are 100 centimeter in 1 meter. 1.72 multiplied by 1 is equal to 1.72. Divided by 100 is equal to 0.0172. 20,000 Hz multiplied by 0.0172 meter is equal to 344 meter per second. We have now the velocity of letter D.
This problem shows the relationship of the frequency, wavelength, and the velocity of the sound waves, in which the frequency and the wavelength is inversely proportional, as the frequency getting higher, the wavelength getting shorter at a constant velocity.
A 600 Hz sound of velocity of 1087 feet per second in the air and a velocity of 4920 feet per second in the water. Find the wavelength of this sound in the air and in the water. Given the frequency of 600 Hz and the velocity of sound in the air 1087 feet per second and the velocity of the sound in the water 4920 feet per second. And the problem is to find the wavelength in air and water. We are going to convert all the units into SI base units. We have 0.35 meter in 1 feet. 1087 multiplied by 0.305 divided by 1 is equal to 331.54. And the other one, 4920 multiplied by 0.305 divided by 1 is equal to 1500.6. Our given now is ready to solve. From the equation in getting the velocity, we could also derive formula in getting the wavelength.
In order to remain the symbol lambda or wavelength itself, we are going to divide both sides by the frequency or the small letter f. Cancel f and f, we have now the formula in getting the wavelength. Wavelength is equal to velocity divided by the frequency.
Substitute all the given value. We have the velocity of 331.54 meter per second and a frequency of 600 Hz. 331.54 meter per second divided by 600 Hz is equal to 0.553 meter. We have now the wavelength of sound in the air. We are now solving the wavelength of sound in water. Substitute all the given value. Velocity is equal to 1500.6 meter per second and a frequency of 600 Hz. 1500.6 meter per second divided by 600 100 Hz is equal to 2.501 meter. We have now the wavelength of sound in water.
In air, the wavelength is 0.553 meter, and in water, the wavelength is 2.501 meter. That this problem implies that the sound travels faster in water than in the air at a constant frequency, and having longer length of wave in the water than in the air.
A wave has wavelength of 3 meter. Calculate the frequency of the wave if it is a sound wave and a light wave. Take the speed of sound as 343 meter per second and the speed of light as 3.0 times 10 raised to the power of 8 meter per second. And now, let's identify the given. We have wavelengths of 3.0 meter and the speed of sound 343 meter per second. And the speed of light 3.0 times 10 raised to the power of 8 meter per second. We have the equation in getting the frequency, the velocity divided by the wavelength. Substitute all the given value. We have the velocity of 334 and the wavelength of 3.0. 334 divided by 3.0 is equal to 114.33 Hz. We have now the frequency of the sound wave. Let us now proceed to the second problem. Substitute all the given value. We have the speed of light 3.0 times 10 raised to the power of 8 and the wavelength of 3.0. 3.0 times 10 raised to the power of 8 divided by 3.0 is equal to 100,000 Hz or 1.0 times 10 raised to the power of 8 Hz. We have now the frequency of the light wave.
On this problem, sound wave has the frequency of 114.33 Hz, and light waves has the frequency of 1.0 times 10 raised to the power of 8 Hz. It shows that the speed of sound or the velocity is directly proportional to the frequency. This entire topic implies the relationship of frequency, wavelength, and wave speed, which the frequency and the wavelength is inversely proportional, and the wave speed or velocity is directly proportional to frequency as well as the wavelength.